Okay, hello everyone. Let's talk about the homework too. First, for the question one, um, this data is to use the historical credit card and application data from the ABC Bank to train like application for like approved or reject, and there's a combine of AUC accuracy, precision, and recall to select like a more suitable development solution, and explain like the impact of data preparation and the feature engineering on the result. So the data contains total of 9,709 record and 20 fields, and among them, target is the binary classification label. 1 indicates approval and 0 indicates rejection. So the classifier include basic information, asset status, family structure, account duration, income, age, work experience, and we also like 5 category variable like income, education, family, housing, and occupation. So first we check the missing value and the duplicate entries. So it's showing that there's no missing value and no duplicate rows, showing like the data clean process was like low cost and could directly proceed to the next stage. So for the true status perspective, the mean value of the target is about 0.132. So showing like 13% of the sample were approved, and this is showing like this is imbalanced, and like therefore like mainly focusing on like accuracy can be like very risky, and the model can be achieved a high accuracy rate simply by like frequently predicting like rejection, but like in practice may missing out like improvement like customer who should have been approved. So the code attempt like two types of encoding for the category variable like label encoding and binary encoding, and this results show like these two encoding methods perform like almost like identical in the experiment. So the code has start by using traditional model, like the logistic regression and like a random forest, and then we use the H2O auto ML to train more models like the GBM, XGBoost, DRF those to compare with AUC, the accuracy, precision, and the recall to the leaderboard, and um, also, I personally try to use the light GBM to also understand changes in the precision and the recall. So for question two, so credit card re- approval is a typical issue involving like a risk control and operation efficiency. So if, for example, like if a wrong customer are classified, the cost could be like a loss from the bad debits, or if if like a wrong reject a good customer, we lose the customer and the profit. So the first one is kind of like precision is high to like reduce false positive, and the other one is should be like the recovery should be high. So like the reduce so to reduce like false negatives. So um, so we can just not like simply looking at one metrics. We should be looking at both. So why logic regression is suitable? So there's like an advantage for it. So it's like strong interpretability and high speed and suitable for like serving as a baseline model and explaining business logic. And in the command scenario, logic regression is also more likely to like enable the compliance team to understand like direction of the impact of variable. And why random forest is suitable? Well, capable of like handling nonlinear data and also like relatively robust outliers, and able to like output like feature importance. Um, showing for example like the importance feature like showing like age, years, length, total income, those stuff can help like the approvals to, like knowing more. And why choose the H2O like AutoML, XBoost, GBM? Well, these are like performed like the best on the structured tabular data and can automatically learn to the combination of features. So for question 3A, so the classing methods can be cause like uh, artificially high accuracy, And if the model tends to be pretty like zero, which is reject, the accuracy might be very high, but the recall will be poor, and in the practice we see the reject a large number of good customer. So for 3B, I think, um, well, there's no like omission or like repetition. Like this process is clean and the model training is like more suitable, and maybe like the customer imbalance has been like identified, but if only like the default threshold is used, only the accuracy is considered, the incorrect conclusion will be drawn, I think. For 3C, well, in the context of the imbalance problem, I think it's recommend to like shift the optimization objective from accuracy to metrics, like the pre-AUC, like the F1 and like the recall and precision. And for the last question, I think a single threshold is difficult to balance the profit and risks. So I think more reasonable approach is like hybrid post, like combining automation with like a manual review. Like use the XG boost. XG boost I think is the highest value for the accuracy and the precision and the recall. So I think like if we select like a development like can based on the overall classification performance, I think this option probably is the best one. And that's the answer for the prompts 3 questions. Thank you.